All right, we're going to do another example, and this one is going to have, I'm going to do it with what's called a tree diagram. All right, so let's say I want to calculate the probability. So we're going to look at families with 3 kids. And I want to say, well, what's the probability of if I have a family with 3 kids that they have 2 boys and 1 girl? All right, so I could list this out. There's different ways of listing it out. I could just list it. I could say, okay, one way is I could have all boys. Boy, 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 right? And then I could change this one to a G, so I can keep these the same and then change the last one and then the second to the last one and then the first one, right? So then I could say, okay, what about boy, boy, girl, right? So now I'm going to change this one because I'm out of options there. So now I'm going to change this to a girl and I'm going to change the other one back to a boy. So we got boy, girl, boy. And I'm going to change this one, boy, girl, girl. All right, so now I've already went through the last 2. Now I'm going to change this one. And this will be a girl. By the way, whenever I change, when I go up one level, all right, I can the rest of them are behind me. So I can just do, this will be girl, boy, boy, girl, boy, girl, 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 boy, and girl, girl, girl. All right, so that's one way to do it. All right, so when we have a problem like this where I have stages, I have the first kid, then the second kid, then the third kid. So this is a 3-stage problem or a 3-stage situation. I can use what's called a tree diagram to come up with my sample space. All right, so here what I can do is so I can start with the first kid. The first kid is either a boy or a girl. And I'm going to draw a little tree there, all right? So either a boy or girl. So then if the first kid is a boy, then the next kid is either a boy or a girl. And the same for this one. So this one would be a boy or a girl. This one would be a boy or a girl. All right, so this is the first kid. This is the second child. I got one more child. So for each one of these combinations, like this one would be, if I follow the path here, I got boy, boy, or boy, girl, or girl, boy, or girl, girl. Then I would have 2 options for the last kid. Boy, girl, boy, girl, boy, girl, boy, girl. And then if I count the last, this is the third kid, right? So what this means this path means boy, boy, boy. And this one is boy, boy, girl. And then I got boy, girl, boy. And so on. Let's see, boy, girl, 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 boy, boy, girl, boy, girl, 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 boy, girl, girl, girl. So, so now I have all of my options, and again, at the end, I count them. I got 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 possible outcomes. And these are all equally likely, as long as having a boy or a girl is equally likely. And it's actually not exactly the same. So there is a difference, but if we were using classical probability, we would say, okay, there's a half a chance of this and a half a chance of that. So for each one of these outcomes, for the classical probability, the probability of each outcome, is 1/8 for each combination.